Before starting exercise 4.3, we must know that what are some of the rules to follow in integration by parts. Basically, we have only three main rules that you will follow in integration by parts questions. For example, you have x ln of x dx, and consider an example x sine of x dx, and consider the third example as sine of ax e raised to power x dx. Now you know that what is the formula for integration by parts. In that formula we have to specify the first function and the second function. For finding that what we should take the first function and the second function, you must keep in mind these three examples. The first one is x ln of x. Whenever you have two functions in multiplication form, that can be integrated easily by using integration by parts. For that purpose, we must know that what is the first function and what is the second function. For that, you have to check in both of these functions, you have to check which function have no integration formula. Like x has the integration formula, ln x has no integration formula. So if any function has no integration formula, just specify it as first function and the second one, remaining one, as the second function. Now consider this example x sine of x. Now x has the integration formula, also sine x has the integration formula, so both of them have the integration formulas. So move on to the second rule, that is differentiate separately both of them. The differentiation of x will give us 1 and the differentiation of sine x will be cos of x. Now you have to observe which function on differentiation will be reduced. On differentiation, by taking the differentiation separately, you saw that x is reduced. So you have to consider that reduction function as first function and the remaining function as second function and the remaining one as second function. Now the previous one, the first rule was you have to find like which function has no integration formula. If any function has no integration formula, then quickly name it as first function and the remaining one as second function. If both the functions have integration formula, then check their derivation. Check their derivatives, differentiate them. The function which will be reduced by taking the differentiation, that will be considered as the first function and the remaining will be considered as the second function. Now the third rule is, I have example sine ax e raised to power x. Sine ax has also integration formula. E raised to power x also have the integration formula. So we cannot use this first formula rule. Now find out the derivative separately. Sine ax will give us cos ax into a. E raised to power x differentiation will be e raised to power x. We cannot tell that anyone is reduced or not. We cannot specify now that if this function is reduced or if this function is reduced. We cannot separate that. So you can take them as first or second or first. It's up to us now. We can name them, any of them as first function and any of them as second function. And quickly just write some name of this integral. Like I have given its name as I. You can give this integral, whole integral, as any letter a, b, and any letter you can. Just let that integral to some alphabet and specify them, any of them as first function and any of them as second function. These three rules, if you just keep these three rules in your mind, then you can easily do integration by parts. The first one was you have to check whether which function cannot be integrated. Just specify it as first function. The second one was if both of them have integration formulas, then take their derivatives. If the differentiation will reduce any function, give it as name first function. Third one was both of them have integration formula. If both of them are differentiated, none of them is reduced. So just you can give them any name, first or second as first, and just quickly name this integral to any alphabet. I hope now you got these three rules. We will follow these three rules in exercise 4.3. So starting from exercise 4.3, question number 1. Before starting the formula, what is the formula that you will use in integration by parts? The integration by parts is you will write first function into integration of second function. First function multiply by integration of second function minus integral sign derivative of first function into integral of second function, and this whole thing dx. This is the same thing that you have to write here. Both of them are same. So what is the formula of integration by parts? First function into integration of second function minus main integral sign derivative of first function, and this integration answer as it is here, dx. Exercise 4.3, question number 1 says you have to integrate x secant square of x. Now x has the integration formula, also secant square of x has the integration formula. Both of them have integration formula. So move on to the second rule. Take their differentiation separately. X, if we take the differentiation of x, it will be reduced to 1. So just consider first function as x and secant square of x second function. Use the formula first function into integration of second function. Integration of secant square of x is tangent x minus main integral sign derivative of first function into integration of second function answer, that is this same thing, dx. Now just simplify it. We will be left behind here integral tangent x, that is equals to ln secant of x, and the rest of things will come as it is, and plus constant of integration. Question number 2. Take the integration of x cosecant square of x. Both of them have integral formulas. Now differentiate both of them. X is reduced on differentiation, so just name it as first function and cosecant square of x as second function. Using the formula of integration by parts, first function, this is x into integration of second function. Second function is cosecant square of x. So second function is cosecant square of x. Its integration will be minus cot of x. That will be written as it is here as well. Now minus, this is the formula minus sign, main integral, derivative of first function. What is the first function? X, and the derivative of first function will be 1 into integration of second function dx. Now open all these things and simplify. We know that integration of cot of x is ln sine of x. If you don't know its direct formula, you can also write it like cos of x over sine of x. Now you see sine of x has the derivative in the numerator, so it can be written as ln sine of x plus c. Third question is integrate x raised to power n ln of x. X raised to power n has the integration formula. Now ln function has no integration formula. So just quickly write first function in with this ln x. Second function will be x raised to power n. Now using the integration formula, first function as it is, first function, this is first function, into integration of second function. Integration of x raised to power n is x raised to power n plus 1 over n plus 1. Formula minus sign, main integral, derivative of first function, that is 1 over x, into integration of second function dx. Now simplify all these terms. This is a constant term. This can be taken outside. We will let x raised to power n plus 1 over x. Now the bases are same, so their powers will be subtracted if they are in fraction form. So we will be left behind x raised to power n. So we got x raised to power n integral formula, that will be integrated as x raised to power n plus 1 over n plus 1 plus c. I have taken 1 over, this is n plus 1 into n plus 1. This will give us n plus 1 whole square. I have taken this outside. So this is the final answer of our question number 3. Question number 4. Integration of x square arc tangent of x dx. Arc tangent of x is tangent inverse of x. X square has the integration formula, but tangent inverse of x has no integration formula. So just specify it as first function and this one as the second function. Now using the formula of integration by parts, first function will come as it is into integration of second function minus main integral side, derivative of first function, derivative of tangent inverse of x is 1 over 1 plus x square into integration of second function, that is the same thing, dx. Now I will take this three, the rest of things will come as it is on the left side. I am just solving the right side integral. 1 over 3 will come outside, left behind x cube over 1 plus x square. In the numerator we have cube, in the denominator we have square. The power of numerator is greater than power of denominator. So this is an improper fraction. So we will just divide it as this denominator will be written outside and numerator will be written inside. Now divide x cube with x square. If I divide x cube with x square, I will get x. So just write x here. Now multiply x with this whole term. We will get x plus x cube. That can be written as this. Now change the signs. This will be cancelled. We will be left behind with minus x. Now the rule how we are going to write this whole thing in fraction is you have to move in this order. You have to move in this order. Just write this x first. I have written this x first. Then minus x over 1 plus x square. Minus x over 1 plus x square. Now we have two functions that is separated by subtraction in integral formula. Just separate this integration into two parts, towards the x and towards x over 1 plus x square, like this. Now this can be easily integrated as x square by 2 plus 1 over 3. Okay, 1 plus x square, if we take derivative, we will get 2x. We can make this 2x here in numerator. So just multiply it with 2 and also divide with 2. Now you see this denominator has the derivative in numerator, so it can be written as ln 1 plus x square, like this. Question number 5. Integration of secant cube of x dx. Secant cube of x, it has no integration also, this is one function. We will just split it into the two functions as secant square of x into secant of x. Now you see secant square of x. Secant square of x has also integration formula. Secant of x has also integration formula. So first rule is not applicable here. Just go towards second rule. Find the derivative separately. We will again see there is no reduction in the functions. So we can just specify any of them as first function and any of them as second function. But we will also let them equals to some letter, alphabetic letter. Just I have written it I. This is capital I and this is Roman 1 and Roman 2. Don't get confused with this. This is Roman 1, Roman 2 number and this is alphabet capital I. Now first function. First function will be written as it is. Integration of second function, that is tangent x, minus integral sign, derivative of first function secant x, derivative of secant x is secant x tangent x, into integration of this second function is tangent x dx. Secant x is written as this, tangent x into tangent x is tangent square of x. I am converting this whole thing into secant. I know very well that 1 plus tangent square of x is equals to secant square of x. This is an identity. So I can take tangent square of x out of this and I will get secant square of x minus 1. Just multiply it inside. We will be left behind secant cube of x minus secant of x. Separate this integration as minus secant cube of x dx minus minus plus secant of x dx. Now this secant of x dx, you see this is the same question and that we have written as capital alphabet I. So just replace this whole integral with capital I. That is the reason that why we let it equals to some alphabet. Because in this third kind of rule, we always get the same integral inside while solving this question. So I just replaced this integral as I. Now integration of secant x is ln secant x plus tangent x. This is minus I, it will be moved on left side and it will give us I plus I, that is 2I. 2 is multiplying here, so divide it with on the right side. So we will get I is equals to 1 by 2 secant x tangent x plus ln secant x tangent x plus c. And you know this I is this our same question. So we just integrated this question number 5. I hope you understand this till question number 5. For the remaining questions, the next video will be uploaded soon.